Hello everyone, welcome to my YouTube video lecture series of the subject Basic Electrical Engineering. In previous videos, you have seen some topics of this chapter, that is transformer. In this video, we are explaining the concept of three-phase transformer. So you are going to study about the concept of three-phase transformer. So first of all, what is the use of three-phase transformer? So we know that the generation of electricity is always in three-phase manner. Transmission is also in three-phase manner. Distribution is also in three-phase manner. Only the consumer may be required, domestic consumers may be required a single phase. So electricity is always generated in three-phase manner. So if electricity is generated in three-phase manner, then the device must be used to increase and decrease the voltage level without changing frequency is the three-phase transformer. So we are studying the three-phase transformer. Three-phase transformers plays an important role in any type of system. So the transformer, that is the three-phase transformer for three-phase circuits, we have two methods to construct a three-phase transformer. We have studied a single phase transformer. So you can take three individual single phase transformer, and by interconnecting that three single phase transformer, you can make a three phase transformer. And the another approach to construct a three phase transformer is the common core for all three phase winding. Three phase transformer is used nowadays because of its very nice features, and that features are: it is lighter, it is smaller, it is cheaper, and it is more efficient. That's why we are using a three phase transformer. There is an advantage that each unit in the bank could be replaced individually in the event of fault. However, this does not apply to the combined core case. So that's why we are using a three phase transformer. Now let's see the three-phase transformers construction. So we can say that how the core of compact three-phase is built. So three windings will be there. So three fluxes will be there, and that three fluxes are phi A, phi B, and phi C. And the addition of this flux, that is phi A plus phi B plus phi C, is equals to 0. And we can say that central lag can be removed. So you can see that there are three cores are there, and these three cores are just like the core type of transformer. If this is first transformers winding, if this is second transformers winding, and if this is third transformers winding, then EMF will be induced in this three winding. Flux will be produced in this winding, that is phi A, phi B, and phi C. And you can check the direction of all these flux. And these three flux are 120 degree apart from each other, as we have discussed in case of three-phase circuits. So basically, these three flux are zero at the meeting point at the central link. So you can remove the central link from this construction. Now let's see the types of transformer. So as I told you, according to the construction of core, there are two types of three-phase transformer. First type is by using three single unit of single phase transformer, and second is the single unit of three-phase transformer. So we will discuss these two transformers one by one. First, let's discuss three single unit of single phase transformer, and by interconnecting the three units, we get the output as a three phase transformer. For that, consider this diagram. In this diagram, you can see that there is one transformer, single phase transformer here, there is another single phase transformer here, and there is another single phase transformer here. So three single phase transformer is on screen. Now, you know that half of primary winding is available on one link and half of primary winding is available on the second link. So this is the primary winding of the first transformer. Half secondary winding is one link and half secondary winding is on the another link. So this is the secondary winding of the first transformer only. And similar here also, P and S, that is the primary and secondary winding, and P and S, that is the primary and secondary winding of the third transformer. So this is transformer 1, this is transformer 2, and this is transformer 3. So now what we have to do is we have to interconnect all the primary and secondary winding of this transformer to get the effect of three-phase transformer. So here we can use the methods, that is star and delta method. So here we have connected the upper winding, that is the primary winding, in star connection. So how star connection is made? The similar or the common terminal from all three windings should be connected together. So here the ending terminal of all the primary winding is connected together. So the ending terminal of primary winding is here. It is gone to the ending terminal of the primary winding of the second transformer, and it is going to the ending terminal of the primary winding of third transformer. So we have connected all the ending terminal of all three windings together, and the starting terminal is given above to give the main supply input, because we need to give the three-phase input. So this three terminal is known as the inputs. Now let's talk about the secondary. You can connect secondary winding also in star or in delta. Here it is connected in delta. So how delta is connected? The finishing end of the first winding should be connected with the starting end. The finishing end of the second should be connected with the starting end of third, and the finishing end of third winding should be connected with the starting end of the first. And at these three lines, three terminals are taken out to give the output to our device. So first junction is here, second junction is here, and third junction is here. Name them A, B, and C. So this is given to the load or the output. So this is nothing but the bank of three single phase transformers. Now let's talk about the second type of transformer, three-phase transformer, and that is single unit of that three-phase transformer. So you can consider this diagram. In this diagram, you can see that there is only single unit of single core available, and this is kind of cell type of core, and on this core there are three links. So what we will do is, the primary winding of the first phase should be connected here, primary winding of the second phase is connected here, and primary winding of the third phase is connected. Similarly, secondary windings, first transformer secondary winding, first phase secondary winding, second phase secondary winding, and third phase secondary winding is connected. Now we need to interconnect this primary and secondary winding to form a three terminal, that is the three phase input and output. So here again we are using the star connection. We have just made a common terminal, common wire at the finishing end of this primary winding, and starting winding is taken out to the input side. For the secondary winding, we are using the delta connection. So the finishing end of the first winding is given to the starting end of, here the finishing end of second is given to the third starting, and third finishing end is given to the first starting. And three terminals are taken out, bring out from these three windings. So it is known as the output terminal. So this is nothing but the single unit of a three-phase transformer. Now, to connect the primary and secondary winding, we are having two options. To interconnect the three-phase winding, either we are using the Y, that is the star connection, and delta connection. So it provides total four possible combination for the three-phase transformer, and that total four combinations are star-star connection, or you can say Y-Y connection, star-delta connection, delta star connection, and lastly delta delta connection. So let's see one by one all types of connection in three-phase transformer. Either it is the three units, either it is the single unit. We have to interconnect the three-phase winding. So first connection is the star-star connection. So you can take this simple schematic diagram, and in this schematic diagram we have used three transformers here. Instead of representing our transformer via core, we have just used the symbols. So this is symbol of the first transformer, this is symbol of the second transformer, and this is symbol of the third transformer itself. So you can see that the finishing end of the all the transformer are connected together, and the starting end is taken out as a supply mains input. So this is known as a star connection. Now we have to connect the secondary winding also in star. So you can see that the finishing end of all the windings are connected together, and starting end is taken out from it. So this is known as the load or the output. So this is known as a star-star connection. So in this way, you can connect the star-star connection. That was the schematic diagram. If you want to draw the winding diagram, then star connection can be drawn like this, and the star connection in secondary winding can be drawn like this. The voltage at between two line is given as V, and the phase voltage is given as line by root 3. I is the current. If you want to find the value of the secondary transformers rating, then you have to multiply and divide with K. K is the transformation ratio. Now let's talk about the delta-delta connection. So you have to connect primary winding in delta, you have to connect secondary winding also in delta. So the finishing end of first winding is connected with the starting of second, finishing of second is connected with the starting of third, and the finishing of third is connected with the starting of first. Three terminals are taken out from these three junctions, so it is known as the supply means or the input. Now let's talk about the secondary side, and finishing end of first with second, finishing of second with third, and finishing of third with first. So this three terminal ABC is known as the load output. So this is delta delta connection. If you want to draw the windings in delta delta connection, then it will be like this. So in this delta delta connection, you can see that these windings are drawn in delta, these windings are drawn in also delta. Here voltage will be same, but current will be different. This is line current. If you want to find the phase current, then you have to divide that by root 3. If you want to find the secondary quantity, then you have to multiply and divide. Again, as I told you, either you have to divide the current and you have to multiply the current to get the secondary parameters. Now let's talk about the third type of winding, that is the star delta winding. That means primary should be connected in star and secondary should be connected in delta. So you can see that we have made common terminal from the finishing end and we have taken three terminals out from the starting end, that is ABC, and this is known as the supply means. In the secondary winding, we have connected finishing with starting, finishing with starting, and finishing with starting, and three terminals are taken, and this is known as the output or the load. So this was the mixed combination. Primary is connected in star and secondary connected in delta. Now let's see the winding diagram of this star delta connection. So this is connected in star and this is connected in delta. Here the again concept will be same. The phase voltage or the line voltage is having some relations. So this is a line voltage and this is a phase voltage. So we know that the phase voltage is divided by root 3 line voltage. So line by root 3 will give you the phase voltage and current will be same. And in this case, what you have to do is you have to multiply K with the phase voltage. So here the phase voltage is V by root 3. So it will be KV by root 3. You have to divide by K in case of phase current. But here the phase and line current is same. So I by K will be the phase current here. So this was all about the third type of connection, that is star delta connection. Now let's see the fourth type of connection, that is delta star. So that means you have to connect delta in primary side and star in secondary side. So for delta, again finishing ending terminals should be connected. Three terminals are taken out from that. It is known as the supply means or input. Here we have connected in star. So three terminals are taken out from that star connection and it is known as the output terminal. Now let's see the winding diagram for delta to star connection. So primary is connected in delta, secondary is connected in star. In primary, the voltage will be same but current will be different. The line current will be I and the phase current will be I by root 3. Here if we talk about the line voltage, then we have to multiply the line voltage by K. But to find the line voltage, or we have to divide the phase voltage by root 3. So this is phase voltage. So first of all, V by root 3 is the line voltage and multiplying with K, we will get the secondary parameters. For this current I, first of all, you have to divide by root 3 and then you have to multiply by. So this is the all four type of connection which we are making in interconnection of three-phase transformers, primary and secondary winding. Thanks for watching this video. Stay tuned.